Have you ever stopped to think about how your GPS figures out the absolute fastest route? Or how economists can even begin to predict what the market will do? Well, a lot of it comes down to solving systems of equations. And today, we're going to open up the algebraic toolkit that lets us do it with perfect precision. All right, so let's get right into it. Graphs are awesome for getting a feel for a problem. You can see the two lines, you can see where they cross, but they have a huge weakness. They're not always precise. I mean, what if the answer isn't a nice, neat number? You're kind of just guessing. And that's where algebra really shines. It gives us the exact answer. And hey, don't just take my word for it. The source material puts it perfectly. Trying to eyeball a coordinate like 49 over 29, I mean, good luck with that, right? There's just no way. We can't rely on squinting at a graph. We need a method that is rock solid, a method that nails the perfect answer every single time. And that's what we're going to do today. So think of these two methods as the all-stars in your mathematical toolbox. Each one is designed for a specific kind of job, and knowing which tool to grab is going to make you an absolute pro at solving these things. Let's get our hands on the first one. Okay, our first tool is called the Substitution Method, and the name really says it all. It's all about this really clever swap that just cuts through the complexity of the problem and takes us straight to the solution. So how does this whole swap thing actually work? Well, it's a pretty straightforward three-step game plan. First, you get one variable all by itself. Then you make the key move. You substitute that into the other equation. And finally, you just solve what's left. Want to see it in action? Let's do it. All right, here's our problem. Two equations, two variables. Now, the first thing we got to do is be a little strategic. We need to pick one variable to isolate. So just take a look. Which one seems like the easiest target? To me, that x in the second equation with no number in front of it, yeah, it's practically waving a flag at us. And this right here, this is the move that cracks the whole thing wide open. Just by rearranging that second equation, we now have a new way to define x. We've basically said, hey, anytime you see an x, you can just think of it as 3 minus 2y instead. Now for the cool part. We take that new definition of x and we plug it right into the first equation. And just like that, poof, the x is gone. We're left with an equation that only has y's in it. And that is something we definitely know how to solve. And now we're on the home stretch. We just do a little bit of classic algebra, distribute the 7, combine our y terms, and boom! We've got our first piece of the puzzle. We know that y is exactly 19 over 29. And there it is. We take that value for y, plug it back into the equation we made in step 1, and out pops our x, the exact solution, 49/29 and 19/29. See? This is the kind of precision that a graph just could never, ever give us. All right, tool number 2. This one's called the Elimination Method, and it is kind of like a mathematical magic trick. Seriously. We are going to make one of the variables completely disappear right before your eyes. So the whole idea behind the elimination method is to make one of the variables, well, vanish. You line up the equations, you multiply them by whatever you need to so the coefficients of one variable match, and then you add or subtract them, and poof, it's gone. Here's how that works. So here's our next set of equations. Now, if you look at them, nothing's really set up for a clean cancellation yet, is it? If we try to add or subtract these right now, we'd still have both x's and y's hanging around. We need to do a little prep work. Okay, watch this. We multiply the top equation by 3 and the bottom one by 4, and look what happened. It wasn't an accident. We specifically engineered it so that the y coefficients are a perfect match. They're both -12. Now we are ready for the main event. And for the big finish, we subtract that top equation from the bottom one. 28x minus 27x is just x, and -12y minus another -12y, that's 0. The y variable is totally gone. We're left with a super simple equation, x equals 2,000. How cool is that? Okay, but what happens when the math just gets weird? Sometimes you follow all the steps perfectly. You're doing everything right. But the answer you get, well, it looks a little strange. Like all the variables just vanish. Let's talk about what that really means. So these weird results, they're not mistakes. They're actually clues. Think of it like the math is trying to tell you something. If you end up with a statement that's just plain false, like -4 equals 0, that's the math saying, nope, these lines are parallel, they never cross, no solution here. But if you get a true statement, like 18 equal 18, it's telling you, hey, these are actually the exact same line. They touch everywhere, so there are infinite solutions. You wouldn't use a hammer to drive in a screw, would you? Of course not. The same thing goes for math. Now that you have these two powerful tools in your toolkit, choosing the right one for the job is half the battle. It's all about being efficient. So how do you pick? It's actually pretty simple. You just ask yourself, which method is going to be faster? If you see a variable that's already by itself, or it just has a 1 in front of it, substitution is perfect for that quick swap. But if both equations are already neatly lined up in that standard form, elimination is your powerhouse. Just line them up and cancel them out. You know, these aren't just abstract math problems. This is the real deal logic that powers so much of our modern world. So the next time you use your phone for directions or you hear about an economic forecast, you can remember the elegant, powerful tools you've mastered today. You've got the toolkit. The only question left is, what problem are you going to solve with it?